Hello everyone, I'm Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on construction of DC generator, means that DC generator means that is DC machine. Construction of the DC generator and DC motor is same machine we can use as a DC generator and DC motor, that we will discuss in the next. So first, what is DC machine? DC machine is an electromechanical energy conversion device which converts from mechanical energy to the electrical energy and electrical energy to the mechanical energy. That machine, electromechanical energy conversion device, is known as a DC machine. It is a DC motor or generator. Now, so what is generator? It converts from electrical mechanical energy to the electrical power, that is DC generator, and this is electrical energy to the mechanical energy, that is DC motor. Now what is DC generator? Same thing here, which output is electrical power. So that is electrical power means when output is electrical power, is that electrical power is DC. So now that machine is called as a DC generator. And if output is which this is the diagram for DC generator, which converts from mechanical energy to the electrical energy. Next, what is meant by DC motor? DC motor is a device which converts from electrical energy to the mechanical energy. Output at the shaft is mechanical energy. It converts from electrical power, that electrical power is DC power, and converted into the electrical power is known as the DC motor. Now see this diagram converts from electrical energy to the mechanical energy at the shaft. Now here, what are the constructional parts? Here, these are the constructional parts in the DC machine, in the generator or DC motor. Now here, what are the parts we are going to study in this lecture? So first part is the body, magnetic frame, yoke. Yoke means outer frame. So next part is poles. Poles are divided into two parts, pole core and pole shoe. Next, field winding. Field winding means field coils or winding, we can call it as a coil. So that is field winding and exciting coil. Next, armature. In the armature core, armature winding. Next, commutator. Next, brushes. Next, bearings. Next, end housings. Next, shaft. At the shaft we can get the mechanical power, and in case of DC motor and in case of DC generator we can give the mechanical energy to the DC generator through the shaft only. So these are the parts, individual parts. Yoke, it is outer frame, and next poles, these are the pole core, and this is the pole core and pole shoe, and this is field winding. Next, field coils, exciting coils. Next, this is the armature core, armature windings, commutator. Next, brushes, these are the brushes, brush holders and bearings, end housing, this one. Next, this is the shaft. So now if you see the individual parts, it looks like this. So now here, yoke, it is the outer frame, and armature and poles, these are poles, pole core and pole shoe, and brushes, commutator, and this is the supply. These are the brushes. Now this is individual parts in the DC machine. Now see the two-dimensional picture. This is the yoke and poles, pole core, this one up to here, and this is pole shoe. Next, this is the field winding. This one. Next, this is stator part. Next, this is the armature core, and these are the points, armature windings. And next, armature core consists of, these are the teeths. So teeths and slots. So these are the teeths and these are the slots. In the slots, armature winding is placed in the armature core. Next, armature core. Armature winding means armature conductors. Next, this is the commutator, and these are the brushes. This is terminal box. Two-dimensional picture. So now I will explain the first slide, first part, that is yoke. That I will explain. That is magnetic frame. So our body of the machine, DC machine. So first one. So this is the real picture of body of the machine, magnetic frame, yoke. So what do you mean by yoke? Yoke is the outer frame. It provides the mechanical support to the inner parts. What are the inner parts? Poles. So these are the poles and interpoles. The interpoles and poles are fixed to this machine. It is a cylindrical shape, hollow shaped cylindrical shape. And so poles, inner parts means poles and interpoles are fixed to this. So such part is known as a DC machine yoke. So what are the functions? So each and every part definition, functions, and material used for that individual part that I will explain in this lecture. Each and every part. So first one, yoke definition, this one, and next two functions. So it provides the mechanical protection, mechanical support to the inner part, mechanical support protection also. Here we will get for inner parts means interpoles and main poles of the DC machine. It acts as a protective cover for the entire machine. Next, it provides the low reluctance path for the magnetic flux. What do you mean by low reluctance path? Flux is always indirectly proportional to the reluctance. If it is a low reluctance path, there may be a maximum amount of flux. So these are the two poles. Suppose poles generates the required flux. So here this is the required flux. If it is a low reluctance path, so there may be more amount of flux. So now if you provide the low reluctance path, there may be a maximum amount of flux. So it will provide to generate the maximum amount of electricity in case of DC generator. So it will require maximum amount of flux. So for that case, we need low reluctance path. That low reluctance path can be provided by yoke. Now here it carries the flux also, main field flux also. It carries the main field flux. So what are the materials we will use here? For small machines, we will use cast iron, and for larger machines, we will use fabricated rolled steel or cast steel. Steel material we will use for larger machine, and iron material we will use for smaller machine. This is regarding magnetic frame, body of the machine, that means yoke. Already this is the outer frame which we can see outside. So now next, inner parts, poles. So pole is divided into two parts. So first one is pole core and second one is the pole shoe. Next, pole, the real picture of pole is it look like this. Actually, north pole and south pole. Here we are using the electromagnets for generating the required flux. So here this is the pole construction. Pole is laminated construction. It looks like this. Why we are using laminated here? To reduce the eddy current losses, and here we are using the silicon steel material to reduce the eddy current hysteresis losses. Now here this is the pole shoe, pole core, and this is the pole core, and this is the pole shoe. Now here the pole definition first. What do you mean by pole? It is a stationary part. It is attached to the yoke only. It is a stationary part, and it produces the main flux. So the required flux is generated with the help of this poles only, pole core and pole shoe in the generator. So that part is known as the pole. Now here pole core is divided into two parts. Pole core and pole shoe are fixed to the yoke with the help of bolts or nuts. And the following are the function. So first it supports the field winding. So field winding, it carries the field winding. So this field winding is in between yoke and pole shoe. It carries the pole core. Pole core carries the field winding. It supports the field winding. Field winding means that is exciting coil. Next, it directs. It will produce the main flux and it directs the. So there is another pole shoe. This is pole core. This is north pole and this is south pole. It generates the main field flux, and this flux, it directs the flux through this area through the, there is a armature in between these two poles. There is a armature, so it directs the, for the next pole, this is next pole, for the next pole to the next pole flux, it directs the flux through the armature only. Next point, and the generated flux distributes in the armature periphery more uniformly. So because of this larger cross-sectional area of this pole shoe, it distributes in the entire air gap. Next, pole shoes have larger cross-sectional area, so reluctance of main magnetic path is reduced. So reluctance of the, it will provide a low reluctance path, means there is maybe a high area. Now, what are the materials? Materials are, we are using here steel material. So steel material we are using means to reduce the eddy current losses and to reduce the hysteresis losses. We are using silicon steel material, and to reduce the eddy current losses we are constructing the pole core with the laminated construction. Next, pole field winding, that means exciting coil. So now this is the winding. This winding is wound on the pole core. This pole core is attached to this yoke. This field winding is in between of yoke and pole shoe and wound on the pole core. So field winding is which is provided between yoke and pole shoe. This is yoke and pole shoe, and next, and is wound on the pole core. This part is known as a field winding. It is an electromagnet when we give the supply. So here this is in between. There is a field coil. Now here it serves, what are the functions? Field winding or exciting coils are used to magnetize the pole core so that the required flux produced in the machine, and next it directs the current passes through the winding. So when direct current is passing through this coil, and it will provide, it set up the magnetic field. When you give the supply, DC current, DC supply, then current flows in this winding and it set up the flux, and it directs the, it will provide the required flux with the help of magnetic pole core. Next, what are the material? For always windings we will use copper wire, copper material we will use for construction of this field winding. Next part is armature. Armature consists of two parts, armature core and armature winding. The real picture of armature core, it looks like this. So this is the armature. The definition. First, armature core of DC generator or DC motor, DC generator or DC motor is a cylindrical shape and key to the rotor shaft. It is connected to the rotor shaft. This is the rotor shaft. Next, the rotating conductor cuts the main field flux, and there is an induced EMF will be developed in the armature core. It carries the conductor. Now there may be a field coils. There may be a required. There is a flux which is generated by poles. So these are the poles, north pole and south pole. So flux lines flows from north pole to the south pole through the armature. So now this is stationary magnetic field, and rotor armature core is rotating. There may be a flux cutting, and according to the Faraday's law of electromagnetic induction, induced EMF will be developed in the armature core and armature conductor. So this is the point. Rotating armature, if it is rotates, flux cuts the armature conductors, and induced EMF will be developed in the armature conductors according to the Faraday's law of electromagnetic induction. That induced EMF circulates eddy currents in the core, which results in the eddy currents. So why we are here eddy currents are generating, so that eddy current losses are produced. So that armature is the rotating part of the DC machine, and reversal of flux takes place and hysteresis losses are produced. There are two types of losses, and hysteresis losses and eddy current losses. To reduce the eddy current losses, we will use steel material, and to reduce the eddy current losses, we will use laminated construction. This core is here laminated construction. Now here the real picture, the actual picture. These are the teeth and these are the slots. In the slots, armature winding is placed. So this is the winding. So now this is the circular plates. So number of circular plates forms the cylindrical shape. It is a cylindrical shape. So the real picture, the actual picture, it looks like this. So the individual parts. This is laminated part, paper by paper means circular plates. If you put paper by paper, that is cylindrical shape. Now this is key way, and these are the slots and laminations, and these are the air holes. Now next, armature cores. What are the serves? So it houses for the conduct. It carries the armature conductors, armature winding in the slots. These are the slots. Next, it provides the easy path for the magnetic flux. It provides the easy path for the magnetic flux from one pole to the another pole. Now, what is the material to minimize this loss? We will use to minimize this hysteresis loss. We will use silicon steel material, and armature core is laminated to reduce the eddy current losses. Two types of losses: hysteresis losses and eddy current losses. Already we discussed in the pole core and pole show. So to reduce the eddy current losses, we will use laminated construction, and to reduce the hysteresis losses, we will use the silicon steel material. So material used for armature core is here silicon steel material for the reducing the hysteresis losses. Next, armature winding. Winding means that is in which EMF will be developed when flux cuts the armature conductor, rotating conductors, and induced EMF will be. That is armature winding. So now here these are the armature conductors, armature winding. Now here this is the core, the real picture. Now here number of conductors forms the coil. So now this is one conductor. So if they are connected in this like this, so like this, this is the coil. So number of conductors in the form of coils in the slots, they are placed in the slots in the armature winding. So now they are interconnection of conductors, also called as a winding. That winding is known as the armature winding. Now this is the armature winding. These are the armature windings. Now here this is the armature winding. So in the armature winding only electromechanical energy takes place, which converts from electrical energy to the mechanical energy in case of DC motor, which converts from electrical energy to the mechanical energy. In case of DC generator, mechanical energy to the electrical energy. So now here mechanical power is converted in the electrical energy in case of DC generator. Electromechanical energy takes place in the armature winding only. Now the material used for this armature winding is this copper wire only. Field winding also we will use copper wire. For winding purpose, we will use always copper material only in the machines. Now here there are two types of windings. So lap winding, and there is maybe a wave winding. So lap winding means number of parallel paths. Number of parallel paths equals to number of poles in the DC machine, and number of parallel paths equals to 2 only in case of lap winding and in case of wave winding. So this concept we will use in the induced EMF concept. Next, commutator. What is meant by commutator? This is the real picture. This is the commutator diagram. The commutator means here which converts from alternating AC voltage to the DC voltage, that I will explain in the next slide. So now a commutator is a component of armature part that is connected to the armature, and this uses the copper bars, that means the commutator segments, to connect each armature coil. So segments are connected to the each armature coil to the brushes through the brushes. Now next point. So it is the most important. What are the functions here? So first function. So rotating conductor. Now here it connects the rotating conductor to the stationary external circuit through the brushes. Now here see this diagram. Here these are the conductors. These are the conductors and these are the brushes. And there may be external circuit. Now here this is the commutator circuit. It connects the rotating conductors to the stationary external circuit through the brushes only. Now here next function, it converts alternating current induced in the armature conductors into the unidirectional current. So first in the generator principle already we discussed. So this is the one revolution, one complete full cycle AC EMF will be generated. This diagram it looks like this. This is the voltage induced EMF. Now here this is a bidirectional current, so it will convert from bidirectional current to the unidirectional current. It converts from AC to the DC. In case of this is in case of DC generator, and in case of motor constructional, alternating torque into the unidirectional torque produced in the armature in the motoring action in case of motor condition. Next, material used for this is actual picture of commutator. So in the previous one, this is the complete machine I have shown. This is the individual part construction. Now here commutator is a cylindrical shape. It is made up of material used for this commutator is wedge shaped hard drawn copper segments. So now here segments are insulated from each other by thin sheet of mica material we are using. So segments are separated, insulated from the each other. Now here segments are held together by means of V-shaped rings that fit into the V grooves cut into the segments. Next, each armature coil is connected to the commutator segment through the razor. Next, brushes. Brushes main purpose here. So here what are the brushes? Here these are the brushes. So these are the conductors. This is the armature core. These are the commutator segment. This is the shaft, and this is the brush. So what is meant by brush? So this is the form of connecting link between armature winding and external circuit. So external circuit is stationary and armature is rotating. There is a we required some part from rotating connection of from rotating part to the for connecting for transferring rotating EMF to the stationary part. So first here there is a firm connecting link between armature, this is rotating, and the external circuit is stationary. So that part is known as the brush. There are it is a rectangular shape. This one, see this diagram. So now here rectangular shape. It is now brushes are housed in the rectangular box and shaped with brush holder or brush box, and these brushes are held in the particular position around the commutator by brush holders. Now only the function of the brushes here we are what is the material we are using here? Carbon brushes are we are using to collect the currents from the it is connecting between the this rotating conductors and stationary magnet through this commutator. So it is connected, it collects the currents will be generated in the conductor current when flux cuts the conductor and induced EMF in north pole and south pole. Flux cuts the conductor and induced EMF will be developed in the armature conductor, and this is alternating current. So now this commutator segments convert from alternating sub EMF to the unidirectional EMF, and this brushes collects this currents from commutator signals and give it to the stationary external circuit, and these are made up of with the high grade carbon material only. Carbon material is used for brush. Next, house endings. So here this is the house ending. Now what is the main function? Here they are attached to the end of the main frame, that means yoke. and bearings. These are the bearings. Now here the front housing supports the bearings and the brushes. So for brushes and brushes assembly, brushes box, and whereas uh, rear housing supports the bearings only. So first one, front housing, there are two parts, front housing and rear housing. So front housing only for this brushes and bearings, and this is rear housing only for bearings only. Now bearings and brush assembly, and whereas this one already we discussed. And next, bearings. So bearings are, these are the bearings for smooth operation of any rotating machine. We will use bearings in the fans, in any machine, any electrical, electromechanical machines. We will use bearings. So what are the function of bearing is to reduce. If you reduce the friction, there may be a smooth operation in the rotatory and stationary parts, and it reduce the function of bearing is to reduce the friction between rotating and stationary part of the any machine. Now here the bearings must always lubricant, that the bearings property always lubricant property for smooth operation and for longer life of the machine. Now they are fitted to the end housing, and for smaller machines we will use ball bearings, and for heavy duty DC machines we will use roll bearings and ball bearings we are using. For small machines ball bearings, and for larger machines we will use roller bearings. Generally, we will use high-grade carbon steel is used for construction of bearings. Next, last part is the shaft. This is the shaft. So, how from the shaft we can, here shaft means we can collect the, it is a rotating part which mechanical energy can be collected from this shaft, and in case of generator, and mechanical energy is given to the shaft in case of DC motor. See the definition first. This is the shaft. This is the shaft. Now here the function of shaft is transfers mechanical power to the machine or from the machine. From the machine means this is motor, and to the machine means that is generator. And all rotating parts like armature core and commutator and cooling fans are key to the shaft. Everything is connected to the this shaft. Commutator, cooling fans, armature core, armature windings are connected to the shaft. Means that is rotating part. Now shaft is made up of with mild material used for shaft is mild steel. So the main property, because of this property, maximum braking strength. So it should be strong. So maximum braking strength, because of this maximum braking strength. So we will use this mild steel material for shaft. So these are the parts. So first one is yoke, pole core, pole field winding, end housing, shaft, bearings, brushes, commutator, armature core, armature winding. These are the parts. I hope all these concepts are clear to you. That's all about this lecture. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.